Hi, I'm Bianca McAllister, and this is Lab 2, Lines of Charge. Similarly to the previous lab, the goal for this lab was to determine the electric force and charge on tapes in order for one to allow the other to float. The difference was in this lab, we were to view the charge as a line charge, where the charge was distributed across the entire piece of tape instead of viewing it as a point charge. And we also were using coding to determine these values and to show a model to view how the charges work. In the previous lab, we determined how much charge is on a piece of tape after a charge transfer occurs, and we also examined the relationship of tape with the charge to different items with differing charges. The experiment for Lab 2 is pretty much the same, had the same procedure as Lab 1, where we, created the charged tapes by using a base tape and a U tape and creating charges via transfer charges. And we created a contraption so that one tape can float over the other. And the principles we used was Coulomb's law and the superposition principle, but the primary difference was that we did not assume a point charge. Instead, we divided the line into pieces in order to obtain a more accurate value. Here, you can just see is my observations and data. The length of tape, which is 0.157 meters, the mass of tape, which was 0.000157 kgs, the separation distance, which was 0.004 meters, and the gravitational force, which was run by mass times gravity, and then the electric force, which was the absolute value of that. And I used the same values from my previous lab in order to incorporate into the code of this lab, and to determine the mass, we used the 1 gram over 1 meter conversion. To start the code, I plugged in my known values, which aren't listed here, but they consisted of like mass, gravity, and the UFPES, etc. And I used my calculated Q from the last lab to begin as a start of my estimated charge, but I tweaked it as necessary towards the end to get more accurate results. In the last part here, which is defined electric field, I found the electric field by using the basic Coulomb law formula, which is shown here, and by defining R by using observation location minus source location. And I assumed that the Q had the same magnitude, so we just used Q squared, but later it ends up canceling. This part of the code basically shows and explains the scaling, which is shown in this first box here. And the scaling was determined by guess and check of when I could see the arrows when I ran my code. Also in this box here, it shows how I created or calculated the electric field and the electric force. So it basically gave us the E field, so I just needed to do the F equals Q times E formula to determine the force, which is also shown here. In the second box over here is what it describes what N is. So N is basically the number of divisions that a charge has, and the more divisions, the more accurate. And this part of the code explains how it goes through each piece of the charge N by going through iterations. And for this last box here, it's basically me creating the electric force arrows and the gravitational force arrows in order to give a visual representation of these forces on the tape, which the model will show in the next slide. So the white arrow is a summation of all of the green arrows, and which the green arrows are basically the ends, and the force that is allowing the top tape, which is the red, to float. So the white arrow in sum represents the electric force. The yellow arrow represents the gravitational force, and the blue arrow is the bottom or the base, or the blue balls are the bottom of the base tape. And as you can see, there's my magnitude of charge, and this was done by adjusting the calculated Q. And all the assumptions I made in order to complete this lab was I ignored air resistance on the moving object, and I assumed that each U-tape had about the same charge and was evenly distributed along the tape, so we could work with N. So for the reflection questions, the first question is basically asking for me to compare the estimated value of charge. So as you can see, those are the two values of charge that I got depending on the experiment. So with the experiment with the tapes as a line charge compared to the experiments with the tape as a point charge, the Q value or the charge of tape seemed to differ by about a half an order of magnitude, with the line charge being larger than the previous experiment where I did the calculations with the point charge. And if I had done it again with the point charge, it would have been practically the same number. And the second question, why do these estimates differ and which value is more likely to be closer than the real value? The estimates differ due to the accuracies depending on the formula. The point charge formula is less accurate than using the line charge, and the line charge is more likely to be closer to the real value because it uses a summation, which gives more accurate values for a charge, because you're using many pieces instead of assuming just one point. Thanks for listening.